Oh, hey folks, welcome back to KEI Fabrication. Alright, we interrupt the regularly scheduled program. We're getting into replacing all the bushings on the leaf springs and new shackles. I'll explain why shortly. Alright, here we go down another rabbit hole, folks. This started out as, hey, while I'm here, why don't I put my traction system on? And I am going to put a Slide-A-Link on this, which is the same principle as Caltrac and Assassin traction bars. And what it is it pivots on the front spring perch. The connection point goes down to the rear end, and this is clamped to the leaf spring, so the forces that go through the system actually try to plant the tire in the ground. Some of you saw this truck previously. I had slapper bars on it, and those work great for where I was, but while I'm in here I got the truck all apart. I figured I'd go for it. Well, what I found was the rear shackles, bushings, and spring hangers were in terrible shape, so I'm going to fix those now. And the reason why that's so important is because if I'm road racing this truck, the only thing that's centering the rear end in the chassis when you're going around corners is the leaf spring bushings, the leaf spring itself, and the rear shackles. Well, if those are all tired, worn out, or flexible, it could lead to failure and cause me to crash, and certainly it's going to limit the performance of the handling characteristics of the truck, both in drag racing and any other form of racing that I'm going to use this truck for. So I'm trying to solve the issue now. Again, you got to go backwards so you can go forwards. This is a 30-year-old or 26-year-old Mazda pickup truck rear spring shackle. And even with all of that, I can barely move this. So what does that mean? Any energy that is available through the traction system is being limited by these really stiff factory bushings, especially if the sleeves are frozen up and things like that, which is why I had to cut these loose. This is by far the worst part of trying to put bushings in a leaf spring. So what I did was I got the leaf spring all prepped by pushing the old bushings out. They were like completely destroyed. And I am going to replace them with, I'm not using aluminum because I still intend on driving this to drag and drive events, and I'm going to replace them with Delrin type material, which is basically a combination of nylon and Teflon. Shouldn't say it's the same chemistry, but the result is the same. It's super stiff. It should not transmit 100% of the noise to the chassis, but still be rigid enough so it'll be somewhere where it's better than the rubber bushing, but not as solid as aluminum, but still provide the freedom. It's going to have a steel sleeve in it, and it'll pivot much more free than a rubber bushing, and almost as good as aluminum. And I'm going to do that for the front and rear. So I'm making custom bushings. I ordered the material. It should be in today. I'm going to turn those on the lathe, and I'll show you what those look like when I'm done. Alright, McMaster Car just dropped the shipment off for me. I really like McMaster Car because the warehouse is regular ground UPS. So this is 4-inch wide by 3 feet long, 3/16 plate stock. Make some brackets for the truck. So that'll help me get over that hurdle. Yeah, so if I order before 3 p.m., because the warehouse is in New Jersey, stuff gets here next day, regular ground. So this is the Delrin material, and if you're not familiar with that, it's a chemistry that is super stiff, but it also has a lubricity to it because it has something similar to like Teflon impregnated in it. So super strong. It says it's super easy to machine. We'll see how that works, but this is going to be my spring eye bushing as well as the rear spring bushing and the shackle bushing. So no excuses. The material's here. I guess we gotta do it. Alright, I had the jaws flipped around to grab the OD of this large diameter material. This was something I was working on for the modified, and I was trying to crank it out before I did the changeover, but I've got so many things that are requiring the lathe right now for the Mazda, I'm going to swap it back over. These are the rear spring hanger tubes that the new bushings are going to go in. I cut them just a little bit oversized so I could face them off at the proper length. So I'm going to flip, face both of those, and I have to make a fixture because I got to modify the front spring hanger on the Mazda. So I'm going to use this as a fixture. I've got to face it off to the proper thickness, which is 2.75 inches, and then I've got to drill a 5/8 hole through it, and I'm going to use the existing hole in the bracket that's going to stay on the frame, and then I need to replace a bracket. I'm going to fabricate a new one. So if I sandwiched all that together and bolted up, it'll automatically position the alignment of the holes. So I'm making a fixture here. It's worth putting the time in to make the fixture because it's going to help accuracy, and the second reason is I've got to do both sides. So alright, here we go. Alright, spent a little time on the lathe. I got these cut to length. I've got the 3/4 inch hole put through, chamfer, lead-in chamfer. It's faced on one side. I did them all because we were set up, the lathe set up. We're trying to do a short production run here. So then I'm going to do a flip, turn to length, and then I got to put them on a fixture to machine the shoulder. Just a make a little spindle for it to sit on. Got the rear spring mount bushings turned. These will eventually go inside here once the step is in place. And I've got the fixture made for the front spring eye bracket. This is the correct width. And I've got a through bore for the bolt that's going to squeeze the whole package together. So the next step, flip, turn to length. And then once they're all turned to length, I will put them on the arbor to do the step. Alright, that's it for now. Alright, so I'm cranking out these plastic bushings, the Delrin from for the leaf springs, and I got my setup. So for the depth of cut, I have a mechanical stop here. And for my horizontal travel, I have a stop here. So I've got a 1/4 inch flange. Turn this down to 1.318, and it presses into the leaf spring bushing just fine. So I've got a little arbor here that I just knocked the nut off, and I'm only turning plastic, so it's you know, it's not like it's building up a ton of resistance, but I have to say I am super impressed with this Delrin material. It pressed in fine. It didn't deform. The hole didn't shrink too much when I pressed it into the leaf spring, and it machines like crazy. The surface finish and the speed is just the best. It makes me look good as a machinist. A lot of times my surface finishes and things are terrible because I'm either in a hurry or my cutting tools are dull. So cool stuff. Alright, I'm on the last of the 8 that were all the same size. So things are going pretty well. I'm going to finish this one up. Alright, I'm doing my finish cut here. I'm going 10 thousandths total, 5 thousandths per side, so it's kind of a finish cut. I always make the last pass towards the shoulder, and then when I draw the tool out, it squares off that shoulder. So last thing I'm going to do is just hit the edge with a file, and then all 8 of these bushings are done. Alright, so there's the finished product. Nice smooth finish. I got the lead-in chamfers for the bushings once I put the bushings in, and then the sleeves that this is going to pivot on. I got a lead-in chamfer here for, that's what the file was all about. I didn't use a cutting tool there because I didn't want to break down the setup just to change the angle of the tool to put that chamfer on there, so just knocking the edge off of the file. The only reason why that needs to be on there is when you go to press it into the bushing that it starts the expansion of the spring eye. So anyway, 8 of these are done. Now I have to do 4 of a different length because the tubes have a different diameter. This is 1.320, and that fits good by pressing in and open up the spring eye, so it gets a good grab onto these. This needs to be 1.35 to go on the inside, and I'm going to make the bushings longer so there's not a gap between the two, so it has the full connection between the sleeve that is going to pivot inside the bushing, and the bearing surface is the entire width of the tube minus a little tiny gap between the two. Alright, let's get to that. Now if that doesn't look factory, I don't know what does. Alright, that's it. That's the last of 12 bushings. So I should have everything I need to put both springs in with brand new Delrin bushings. So my mechanical stops worked out great. Got the right measurements, the right shoulder thickness, and the remainder of this so it goes inside the spring hanger. Perfect. Alright, my mechanical stops worked. Now we can go weld some brackets on the truck. Alright, so I need to modify this front spring bracket, and the reason is because Mazda, actually it's kind of an ingenious idea, but in order to incorporate the traction system that has the pivot bracket and everything, I really need just a hole over here rather than this. So I'm going to trim this bracket off. I'll use it as a template, and I've got some 3/16 plate steel that I'll create a new bracket. And those of you who saw me make that spacer, I will through bolt the spacer, and that'll help me position the new bracket, and I can weld it in place, and it will keep it parallel and perpendicular in the right locations to accurately get the outside of this bracket in position, so I don't introduce any spring bind or anything like that. So step 1, cut this thing off. Step 2, make the new bracket. And step 3, fixture it up and weld everything up. No turning back now. Alright, so some of you might have been asking, why did you scribe the arc there? I did it as a reference. Now, if I need to know the exact center of this, I measured the diameter, and I needed to know the radius, which was the distance from here to the whole center. And then I measured the overall distance from the outside of the circle to the edge, and then I subtracted the radius, and then I got the center from the edge, 0.637. So had to do the math. So that just gave me a reference and kind of gives me the ichrometer, if you will, is with that scribe line there. Am I anywhere near close to what looks correct? So now what I'll do is I'll center punch that. Remember I said on anytime you're doing bracketry, drill your holes first, because I got all of this to hang on to. If I just trimmed out the bracket, now I could be chasing it around. So center punch it, drill the 5/8 hole, and then cut the profile out. Because I know I have to do the same thing to the other side of the truck, I use the finished bracket as my template. And now, because I'm all set up, I'll cut that one out now, so when it comes time, everything will be ready to modify the left side of the truck as well. Now we have two front spring hanger brackets. Alright, I got the outside welded and I tacked it on the bracket that sticks out off the frame. Once I take my fixture all apart, put the truck up in the air, I can get a nice bead all the way along the inside. So this will be attached in 2 locations. So it'll be stronger than it ever was from the factory. Alright folks, when your spring hangers look like this on your Mazda B series truck, it's probably time for some new ones. So that's what we got going on here. I got the tubing cut to replace the bushing holder, and I've got some of these that are going to actually become the bracket that was here. So, and you'll see how that works in just a moment. Alright, so I know what you're watching here is probably going to look a little unsafe, but the belt on my drill press is set really loose, so it'll stall out, especially with a big diameter drill. So the reason why I have it set like that, the reason why I have extra leverage here, is if it does get away from me, it'll go around to the backstop and minimize any opportunity for injury. So here we go. Alright, so what I'm attempting to make is, this used to be connected all the way across. When I cut it off the frame, it was welded here and here, so I have 2 separate pieces. I am replicating this situation here with the angled. I'm using the hole saw to cut away a piece of box tubing to slip a new piece of tubing in. And if I make a lot of brackets, I made out of box tubing. I made these out of box tubing. And the secret to doing this, so you're not chasing it around afterwards, is drill all your holes first and then cut out the geometry and the profile. So what I'm going to do now is I'm going to replicate that angle from the center line up to the ends. I'll cut that on the bandsaw now, and that's why I don't have to go all the way through with the hole saw, because when I cut this, this will all drop out. See if I'm telling the truth or not. So one of the things I did, you saw me, I used a pilot drill that was smaller than the diameter of the pilot drill for the hole saw, and I drilled all the way through to the other side. And what that does is that perfectly lines up, so when I flip it over and I use that pilot hole, it's automatically positioned correctly to line up to the other side. If your table is perpendicular to your spindle, when you drill through like that, and obviously the material you're utilizing has parallel sides, then that pilot method all the way through helps make the stuff that's intended to line up all the way through work properly. So quick technique, I didn't have to lay out both sides, I just laid out one side, transferred basically that all the way through to the other side. The other thing is I intentionally, when I make my material out of bracketry, the inside of the tubes, any structural tubing, has a weld seam. And I purposely position this so when I cut away the part of the bracket that I don't want, the weld seam is what goes away. So that's not present anywhere in the remaining bracket that I'm actually going to use on the vehicle. So some initial strategy and intentionally placing that so it ends up being in a position that doesn't affect your design or functionality, you just kind of have to incorporate that in, and you get used to that as time goes on. Especially when you get it in the wrong spot and it's there and you have to go in with a burr machine and remove it. Alright, I just want to give you folks a little hint on when you're making bracketry that has its end use is going to be where something is welded to it. I'm going to show you a little technique I use. What I'm doing is I'm lining up this piece of tubing is nothing more than just a template that I use as a radius gauge to apply radiuses to different things. So just bear with me here. So what I'm doing is I'm kind of lining up the center of my radius gauge with the edge that is going to be left behind as a result of cutting this away. So, and then I just trace it. And I do the same up top. I'm lining the center of this with the top of the bracket, and then I trace this out, and I do that on both sides, and you'll understand why in just a moment. And to copy Cars and Cameras and a couple of the others out there on YouTube, this is the ichrometer, right? I'm just kind of giving myself a reference mark. I'm not measuring anything, but the end result will be just fine. And then I need to connect the dots here with a straight edge and be as tangent as possible. So what I'm trying to do here is, if I were to cut this to a sharp point, when I go to weld that, it's really going to blow away that corner. By making the radius here, I'm kind of making just a little piece of horizontal material, so when I weld that tube to this, at this point right here, when I do that weld, it's not going to blow that corner away, and it's actually going to allow that weld to sit in there and fill that corner up. So I'll cut this away, I'll show you what it looks like, and then hopefully after I weld it, it'll give you an example of why that works so well. And the end result is, if you just take a minute, throw a little bit of a radius on there, whether you're putting this on with a flapper wheel or a belt sander or something like that, it just makes the bracket look cool, right? So the end result is, cut this away, I make the curve while I'm cutting in the bandsaw, and make the curve while I'm cutting in the bandsaw. Because I'm cutting all the way through, that shape will transfer down to the opposite side. So let's see how I make out. So I'm going to purposefully stay towards the side of the line of the waste material, so in case when it transfers all the way to the other side it's not exact, I have the opportunity to fine tune it so the sides match. And then that also gives me the opportunity to use a flapper wheel or a sanding disc or the belt sander to get the contour that I want. Nice bracket, yes? And I got a funky little waste piece. So now I can stick this on the belt sander, smooth those rough cut edges off, and this will look like it came out of a piece of machinery that manufactured this. So, and then a little, and you can see how nicely that tubing fits in there. And when I weld right here, you can see I've got that little horizontal platform that when I wrap the weld, it's not going to blow that away like a sharp point would be. And you've got some integrity added to the bracket, and a nice little a nice little area for that weld to land in there, so it becomes a true fillet weld. So you can see what I mean by the weld seam in structural tubing is in the part that I'm throwing away, and it's nowhere to be seen in this particular piece that I'm using. Alright, if I'm going to put power to this thing and I'm going to go abuse it, I'd trust these a little more than that, yes? So I just spent a minute or 10 on the belt sander, and you can see I got rid of the sawtooth marks on the edges, and it makes for a nice, you can exaggerate the rounded corners when you're on the belt sander. So I did that, and you can see that the bracket looks pretty cool, and when it's all welded in, it'll have some character to it in terms of it'll look like it happened intentionally. Alright, I'm tacking my spring hangers together. I've double checked the placement of the tube relative to the bracket, and I'm happy with what I'm seeing. So I'm going to tack weld it, and that should make my spring hanger brackets so they're equally spaced. Swap the ground over. Do that one more time. Alright, you might be wondering what the heck I'm doing here, but I need to make new shackles. These are pretty beat, and as you saw with the other spring hanger thing, it was completely destroyed and I couldn't get it out of the spring anyway. So, why am I using box tubing? Well, first of all, if I drill the holes ahead of time, they're going to be perfectly in line with each other. And what I did was I trimmed them all out. And when I did the box tubing, if you saw when I was cutting, I left a little gap here on both sides, and then I did a finish cut with just like an 1/8 of an inch left to cut. The reason is there's a lot of residual stress in tubing, any tubing, and a lot of times as you cut and it relieves that, it'll pinch the blade. And the other thing I wanted to make sure is that when it released, it didn't trap, or if I cut all of them off, then I would either be trying to cut this, because this is the side that's marked, and it would want to tip over, or I'd have to flip it over and kind of measure and cut again. So the reason why I chose to go with the box tubing again is so the holes, when I drilled them, they're perfectly aligned as far as center spacing. And the factory shackles are made out of 3/16. I wanted them a little more rugged because I am going to be racing it. They're not light, but they're strong. So I didn't have any flat stock around, and I certainly could have cut them all the length, stacked them, and then drilled them all at the same time. As a matter of fact, when I shape all of these, you can see I cut little radiuses. I'm going to bolt all 4 of them together with 1/2-inch bolts through the center, and then I will make them all exactly the same size externally, and that's just purely for cosmetics. The next step is I will scribe the bend line in the part, and then I will go over to my press brake and I will apply the bend to get the offset to match what I need for my leaf springs. So I'm going to go ahead and cut this one out, and when that's done, I'll bolt them all together, smooth all the sides out, sand the radiuses so they look like a machined part rather than just something that was cut out with an axe. Alright, let me get back to work. Alright folks, that's it for this time. Remember, if you can't be good, be spectacular.